let us discuss loans, principals, and interests today. In simple terms, you can think of a loan as any type of money that has been borrowed, okay? Any borrowed sum. So if you want to borrow some money from anyone, from any lender, that the amount of money that you take out is the loan. Okay, so typically you hear people taking out loans for, say, a house, or for a car, or for credit card debt, or things like that. That is a loan that you take out to pay something off that you can't necessarily buy because you don't have that large sum of money at the moment on hand. But you know that you will make enough money to pay back the loan to the lender. And so the lender vets you as a person who's going to take out the loan to make sure that you can indeed pay back the amount that you borrowed. Okay? The way they make money is through this thing called interest. So this is the amount of earnings made by the lender on the loan. Okay? And one more thing that we should probably define is the principal. This is something you probably heard being thrown around quite a lot. The principal is basically the balance of what is owed at any one moment. It's like a snapshot of what the loan is. So let's say you take out a $100,000 loan, and then you're being charged some sort of interest on it. You're paying off the loan back to the lender with interest as well. And as you're paying off the loan, you don't owe as much as the original loan. So if you took out a $100,000 loan and you started paying it off in a year's time or something like that, you won't owe the lender the $100,000 that you took out because you paid some of it off. So the amount that you actually owe back is called the principal. So let's say I gave you $100 and you start paying me back off. Let's say I took no interest, and you pay me back, I don't know, $75. The $25 that remains is the principal. Okay, and let's discuss the three most common schemes to actually charge interest to someone who's to a borrower. All right, so there is the simple interest. And really, this is quite simple. And you'll see with the other two schemes that this is comparatively much simpler. The way we can calculate the simple interest, so the interest that the amount of money the lender will make on the loan, is calculable from the following. And I'll just define the variables in a second. Okay, this way. And I is the amount of interest. Amount of earnings made by the and this is going to be in US dollars, let's say, or any type of currency you'd like. So we're in the United States, so we'll deal with US dollars. Okay, principal, as we just defined before, this is the principal, and this is also in US dollars. Okay, so they're both, this and this are in US dollars, meaning that these won't be. Indeed, they're not. And let's talk about little I here. This is the annual. Okay, the annual interest rate. And for this equation to work, it is in fractions. So meaning that it is less than or equal to 1. Okay, it's a positive number between 0 and 1. So if you have a 5% annual interest rate, you would write 0.05. Okay, you won't write 5, but 0.05. Okay. Little n is the frequency that the interest is applied. Okay, and n is the number of payments made towards the loan. Okay, and it is also equal to little n times t, which is time, Okay, and you can easily check yourself that way. T is time. Okay, so I think it make more sense if we look at an example and see how this is applied to understand the machinations behind this. Okay, so let's say as an example. Okay, I have an example here. Oops, let's move this guy around. Okay, example: calculate the interest accrued over 2 months for a $1,000 loan with 12% annual interest rate applied monthly. So let's try to break this down. Okay, we'll try to break this down and make sure that for our equation we're asked for the interest. So we're going to use this. This is for a simple interest scheme. Okay, so we need to be able to find P, little I, big N, and little n to understand how this may work. Okay, so the interest accrued over 2 months for a $1,000 loan with 12% annual interest when it is applied monthly. Okay, so I can tell you from here that the principal is going to be the amount of money that that was lent out. So this is going to be my principal. Okay, now we said that little I is the annual interest rate in fraction. If you look here, usually it will tell you what the annual rate is, which here it is 12%. So this thing here is little I. This is little I. And it's got to be in a fraction, so little I is going to be 0.12. This is still going to be $1,000. Okay, it's going to be $1,000 there. Just move it so you can see it. Okay, and we need big N and little n. Little n is the frequency that the interest is applied. So it is applied, it's being applied monthly. So this tells me what the little n is. Little n is monthly. Little n is monthly. So we'll see what this means in a second. And big N is the number of payments that I made. So big N is the number of payments. So I could do this in one of two ways. I can try to look at it here and see what it is. Or if I don't trust my intuition, I can calculate that from the formula. So, well, let's look at the problem statement, see how many times I actually paid this back. So calculate the interest accrued over 2 months for a $1,000 loan with 12% annual interest rate applied monthly. That means that every month the interest rate is being applied. So every month I am probably making a payment. So over 2 months, that will probably mean that big N is 2 because I did it twice. I have two months worth. So N is 2. Okay, it's just as a number, it's unitless. And if you don't trust yourself, you can look back at the definition here. It is equal to little n times the time. So little n is monthly times the time, and this is t. So monthly times time. And so let's see, the time that it took to pay this off is 2 months, and this is monthly. So if we look at this, this says per month, and this says 2 months. So let's do. It's the same. If you don't trust yourself, just work at that. Okay. So now I can almost put it all in together because I know all the variables. So I know that P is $1,000. So that's P. And I got to multiply it by little I, which is 0.12. Now 0.12 is per year. It's per year. Big N, I've proven twice now, it's 2. And little n, we said, is monthly. So this is once per month. Okay, so let's look at what I want to get out. I want this in US dollars. I want this in dollars. I have this in dollars, so that's cool. So I gotta make sure that all of this goes away unit-wise, so that I can actually get this in dollars. You can't see this, can you? Right, so how would I do that? Well, this has no unit, so that's good. But I gotta make sure that little n and little I and little n have the same unit. So in order to do that, I have to convert this to a per month basis or this to a per year basis. So I'll choose to do this per year basis. So just really quickly, 1 per month. If I want to convert this to, so let's put it like this, 1 over month, and I want to convert this to a yearly basis, well, I'll multiply by a dimensional analysis factor to cancel out the unit that I don't want. So I want month at the top, and I want year at the bottom. Okay, so what I know, well, it's 12 months per year. And so I get that this is 12 per year. So now I'm ready to rock and roll. I can put this back here instead of the 1 per month, and I'll probably get what I need. And indeed, that is true. So I'll put that, let me just go up here, I'll erase this and put that in, and then we should get our result directly. So I, here, again, is equal to $1,000. Okay, so I'm just copying this just with the correct units. This here is 0.12, the interest rate, 0.12 per year. This is times 2. That doesn't look like a 2, does it? And I divide this by 12 per year. I just calculated instead of 1 per month. So now I can just punch it all in the calculator. 1,000 times 0.12 times 2 divided by 12. And when I do that, I can actually get my result, which is $20. So the reason this is called simple interest and not anything else is because if I were to change the number of payments, number of months that I'm looking at, all I have to change here is this. This is the only thing that indexes. Right, so if I'm looking ahead of time, how much am I going to, how much interest am I going to owe in 3 months, or 4 months, or 5 months? All I got to do is change this to 3, 4, 5, 6, whatever that is. This stays the same, and this stays the same. The annual interest rate, right, and the frequency at which this is being charged, both of those don't change. The principal, the original principal, doesn't change either. So that's the only thing that has a potential of changing. And so what you can see is that the interest here, for this particular example, is always going to be $20 per month. Just how it works out. So every month I'm going to have to pay $20 to the lender for this particular loan. So it's very simple to understand, very simple to apply. And wouldn't that be nice if the world looked like that? Because then you can just easily do it all and understand it. But the most common way of charging interest is actually called compound interest. Okay, and compound interest, basically, it's a little bit of chutzpah that they have there, because not only do they charge you interest on the principal, on the original principal, they charge you interest on the previous month's interest. Okay, so you owe them money, and then your first payment, you make a first payment, and your second payment is based on the first payment, and the third payment is based on the first and second payment, and the fourth payment is based on the first, second, and third payments. So that's not great, but that's how it is. That's how it's done, and this is called compound interest. Okay, and the reason it exists is because the lender gets to make more money. And as the borrower, what do you have to say? You need the money, so you'll pay it up. And so it's the same variables as before, only now I'm introducing the fact that like I said, the interest for a particular month is based on not only the principal from the previous month, but also the interest from the previous month. Okay? So let's look at an example and see how this works out. So let's say I have determine the amount of interest earned on a $3,000 loan after 3 years with 2% annual interest rate. Okay, that's also applied monthly. So this is pretty common, by the way, that these things are applied monthly, and that the interest rate is cited on an annual basis. All right. So let's look at that, and we're going to do this both using the compound interest first, and then afterwards we will do it with simple interest, just to show you the difference. Okay, so for compound interest, let's do this here. All right, so again, if I'm looking at the equation up top, I need my principal. So my principal here is $3,000. Okay, times I have 1 plus, well, this is where my units will have to change some. This is still 3,000, so I'm just copying basically here. This minus P is the same, so I'm not changing that. So I'm going to have to try and find I, N, and big N. All right. So I have a $3,000 loan, and we already determined this is principal. After 3 years with 2% annual interest rate. Okay, 2% annual interest rate, that's little I. I is 0.02 per year. Okay, so that's little I. Big N and little n, a little more complicated, but not so much. So I have 3 years here that I did this. So this tells me the big N. 3 years. Okay. And I know that this is being applied monthly. Again, this thing tells me little n. This is 1 per month. So again, this is 12 per year. Okay. N, if you're not sure about this, again, it's going to be N times T, right? And if you're not sure how this works, you just put it in what you have. You know that this is 12 per year, and you know this is done over 3 years. So the years cancel, and I get that N is 36. Okay, so I know big N is 36. So I go back down here, big N here in this, oops, not 3N. This is big N here. So big N here, which is the exponent, becomes 36. My fraction here is I over N. I made sure they're in the same units again. So this is going to be 0.02 as the fraction, as we just discussed here. 0.02 per year. And here I have 12 per year. Great, so my per year thing cancel, and I'm left with only dollars, which is what I want. So when I substitute all of this into the calculator and I work through this, I get that this is $185.35. This is the interest made on this particular loan over 3 years. Okay, if I'm looking at simple interest, okay, I have the same equation as before. I need my principal, so it's $3,000. I need to multiply by little I, which we already just figured out is 0.02 per year. I need to multiply by big N, which is 36, and I had to divide the whole thing by little n, which we already established as 12 per year. I punched that all in, and I get that this is $180. So you can see the compound interest over 3 years for this particular sum for $3,000. For $3,000, it made an additional $5.35. So the lender likes this scheme better because they make more money off of the person who's borrowing the money, the borrower. Okay, and let's discuss really briefly the last scheme of interest, which is called continuous interest. And I'd like to use the same example, so we don't have to redo everything with another example. But these are all similar enough. Okay. So let's look at continuous interest. Okay, and what this is basically saying, instead of doing this once per month, I'm continuously levying interest on the borrower. So basically here, what I'm going to do is look at the frequency the interest is being applied. Start saying once per month, once per year, or whatever. I'm going to just take this to infinity. So n goes to infinity. I'm going to continuously apply this interest. And so how does this work out? Well, if I look at the compound interest equation, I'm going to just take the n to infinity here for this particular equation. Okay? And I'm going to what I'm going to do to make my life a little bit easier is I'm going to define x to be n over I, which is an indexing variable. It will go away, I promise. And if you just solve for n here, it also means that n is equal to xi. So if I substitute these values in here, so if I use these values here, right, I can get rid of little n and little I and stuff like that, and I will get that I is equal to, again, limit as n goes to infinity now, and my p stays the same, and it's 1 plus 1 over x raised to x times I times t minus p. Okay? That's what that is. And by definition, from calculus, by definition, I know that E, the natural number E, is equal to the limit as x approaches infinity for 1 plus 1 over x to the x minus p. So if I apply this particular form here, I could see that for continuous interest, I is equal to P times E raised to the I t minus P. This is going to be the governing equation for continuous interest. I just wanted to derive it for you so you don't think it's coming out of thin air. So let me just put that up here. Continuous interest here is I is equal to P times E raised to the I t minus P. All right. And let's apply the same thing from before, where my principal was $3,000. And I know that this is after 3 years with 2% annual interest, so t is equal to 3 years. Good. And my annual interest was 0.02 per year. So I can put that all in here directly, and I get the following. E times 3 years, and this is 0.02 per year, minus $3,000, and I get that this is 185.51. This is for continuous. This is for compound. And this is for simple. For the same loan, for the same amount of time. Those are the three results. You can see these two are fairly similar. And they're both quite a bit divergent from the original one.